Hi guys, Dr. Justin Salvi here, going through your second semester test. This is question 9 for 4 marks, and this is just theory, so you either know it or you don't, but I'm going to go through it. If f and g are both differentiable, prove the product rule for differentiation. Okay, so the left-hand side here is the derivative with respect to x of f of x times g of x. So we're going to start with that. We've got the derivative with respect to x of f of x times g of x, and we're just going to use the definition of the derivative. This is equal to the limit as h approaches 0 of, now we take our function of x plus h, so in this case it's f of x plus h times g of x plus h minus just the function evaluated at x, so that's going to be f of x g of x all over h. Now the next step is where the little trick is in this proof. We're going to add and subtract the same thing. We're just going to add it and subtract it in a very particular place to make things a little bit easier. So we've got f of x plus h, g of x plus h, and now what we're going to do is we're going to first subtract f of x times g of x plus h. It's a little sneaky thing to remember what you need to add and subtract here, but you can work it out. You'll see where it's going in a moment. So we've subtracted that, we need to add it again. So plus f of x, g of x plus h, and then finally minus f of x, g of x, and it's all still over h. Okay, so we haven't changed anything. We still got this as equal to, because we subtracted something and then we added back exactly the same thing. That was f of x, g of x plus h, and now we're going to cleverly we've done that so that we can factorize out common factors. Over here we're going to factorize out an x plus g of x plus h, so we get g of x plus h, and that we are left with f of x plus h minus f of x, so that's those two terms over there, plus, and in this case we're going to factorize out f of x, and we take that out and we're left with g of x plus h minus g of x. And you can see now why we had slightly different terms here, because in the first case we factorized out g of x plus h, and in the second case we factorized out f of x. So if you can't remember, you can always work out what it is that you need to add and subtract in the middle. Okay, now this is starting to look a little bit more like the derivative of f of x, and this is starting to look a little bit more like the derivative of g of x. We just need to separate them into separate terms. So here we've got, let's just rewrite this slightly, we've got the limit as h approaches 0 of, now I'm going to write this bit first over h, so this is f of x plus h minus f of x over h, and that term there is multiplied by g of x plus h, and then to that we're adding, now I'm going to write the fx term first, fx times this thing divided by h, so times g of x plus h minus g of x all over h. And when you're learning theorems, one of the best things to do is just to write them out a whole lot of times, just to get practice and seeing the tricks over and over again. Okay, now we've got the limit of this over here. Now if all of these are nicely behaved limits, then we can take the limit of each of them separately, which of course we can do, because you'll see f and g are both differentiable at the end. We just got to check that it was actually a legitimate step. So we've got the limit as h approaches 0 of the first one, which is f of x plus h minus f of x all over h, times the limit of this guy over here, the limit as h approaches 0 of g of x plus h, plus the limit as h approaches 0 of f of x, times the limit as h approaches 0 of g of x plus h minus g of x all over h. Now, last step, right. This guy over here looks suspiciously like the derivative of x, and that is exactly what it is. So derivative of f, the derivative with respect to x of f of x. If you were to write this out using limit definition, you would get that multiplied by, right here we've got the limit as h approaches 0 of g of x plus h. Well, h is approaching 0, so g of x plus h is simply approaching g of x, plus, yeah, well, there's no h here, so that's simply f of x. And this guy over here looks suspiciously like the first principle definition of the derivative with respect to x of g of x, which is, I hope, precisely what we were trying to prove. The derivative with respect to x of f times g of x plus f of x times the derivative with respect to x of g of x. These are some very easy marks if you just know your theory. And like I say, the best way to learn theory is just to write it out 150 times or so.